Hello everyone and welcome back to the C++ 3D game tutorial series. In this 35th video tutorial, we will see how to finally make a 3D level. In particular, we will see how to design and implement the camera component class, how to make the first-person camera movements through the new entity and input systems, and in the end, we will see how to easily create a 3D level even with complex meshes. As always, we will face three main parts: requirements, design, and implementation of all the necessary things to make a 3D level. Let's start with the requirements. We need a C++ IDE. In this series we use Visual Studio 2019 Community. The target platform is Windows. The target graphics API is DirectX 11, and last but not least, a bit of knowledge of C++ programming language is recommended. Now we can start the design part. The last time we have seen how to create the mesh component class and how to render easily graphics entities on the screen. Today we will see how to create a 3D level. Let's start by adding the camera component class in our entity package. As usual, let's inherit the component class. As we have seen in the previous tutorials, a camera is mainly composed by the view and the projection matrices, necessary to move the point of view of the player inside the game world. The view matrix is nothing but the world matrix of the camera object inverted. The projection matrix, instead, allows to project the points of a 3D world into a 2D space. Very well, let's start to create the camera component class. Since the view matrix derives directly from the world matrix and we have already handled the world matrix in the transform component, let's add only the projection matrix as attribute. Also, we should add other important attributes, always related to the projection matrix, like the field of view, the screen size, the far plane and the near plane. As usual, let's add the setter and getter methods for our attributes. As we have already done with the mesh component, let's add and handle the camera components inside the graphics engine class. Once our camera component is ready, we can finally implement the first-person camera movement. In particular, we will exploit the player class. In the onCreate callback method, we will create the camera component. In the onUpdate method instead, we will add the logic by exploiting the new input system. The result should be like this. The only thing to do at this point is to make the actual 3D level. So in our myGame class, in particular in the onCreate method, we will start to add a floor, a skybox, a series of boxes placed randomly, and in the end we will see how to add and manage a complex mesh like the Sponsa model, composed by multiple materials. If you have questions, doubts, or comments about this topic, don't hesitate to leave them in the comment section of this video or in the Discord server. The link to the Discord server is available in the video description. Also, if you find these tutorials helpful, please consider to support their development on Patreon. Every single contribution makes the difference, regardless the amount. Very well, we have gathered all the necessary information to start the implementation. As first thing, let's go to the entity package and let's create the camera component class. As usual, let's add the constructor and destructor methods. At this point, let's inherit from the component class. As we have already seen in the introduction, let's add all the attributes necessary to compute the projection matrix. So the near and far planes, the field of view, let's also define a new enumerator called camera type with two types, perspective and orthogonal. And last but not least, let's define the area of the screen. Good, let's add the setter and getter methods. In the end, let's add the most important attribute, the projection matrix. Obviously, let's add a method that allows us to retrieve the projection matrix. At this point, we should recalculate the projection matrix each time we change or modify one of the various attributes we have just added into the component. In order to do so, let's add the compute projection matrix private method. Here we should check if we are dealing with a perspective camera or an orthogonal camera. If we use the perspective camera, let's compute a perspective projection matrix through the setPerspective fo LH function. Otherwise, let's use the setOrtho LH. Once the computer projection matrix is ready, let's call it each time we call one of the various setter methods just created. Let's also introduce a further method called getViewMatrix, through which we should retrieve the world matrix of the entity in which the camera component is placed, but inverted. As last thing, as usual, let's implement the onCreateInternal callback method in order to add and or remove this kind of components inside the graphics engine. At this point, let's go to the graphics engine header file and let's add a set of camera components, in the same way we have done previously with the mesh component ones. Let's remember to add a forward declaration to the camera component class in the prerequisites header file. Let's also clean a bit the graphics engine class. So far so good. Now we can go to the graphics engine C++ file and in the add component method, let's add the camera component to the set of cameras just added. Let's do this by checking the type of the pointer passed as parameter with the dynamic cast operator, as we have already done with the mesh component. Let's do the same thing even in the remove component method. Let's also prevent the user to add multiple cameras, since supporting multiple cameras is an advanced topic that probably we will face in the next tutorials. Very well, now we can go to the update function and here we can start to loop over the set of cameras. And for each camera we should set the size of the screen in order to compute correctly the projection matrix and retrieve the view and projection matrices inside the constant data structure. In the end, let's clear the background with a black color. So far so good, it's the time to implement the first-person camera movement. So let's go to the player class, let's remove all the test code from onCreate and onUpdate callback methods. As first thing, let's create the camera component. Obviously, let's remember to add the camera component header file in the all header file. Let's place also the player entity at -10 units along the z-axis. Let's see if it works. And it works! Everything seems to work, even the resizing of the window. Now we should start to implement the camera rotation through the mouse movements. To do so, we should retrieve the input system. Let's retrieve it by going to the entity class and by adding the getInputSystem method. We have to do the same thing even in the game class. At this point, let's come back to the player class and let's retrieve the input system. Remember to add the input system header file to the all header file. Now, in order to rotate the camera through the mouse movements, we have to call the getDeltaMousePosition that retrieves only the variations of the mouse cursor movements along the X and Y axis of the screen. Apply this variation to the current rotation of the camera and set this new rotation to the transform component through the setRotation method. In the end, let's go to myGameC++ file and in the onCreate method, let's lock the cursor at the center of the window through the lockCursor method. Let's see if it works. And it works! The only issue here is that the cursor is visible, so let's hide it. Let's go to the input system C++ file and in the lockCursor method, let's use the showCursor Win32 API function. So far so good. At this point, let's go to the myGame class and let's implement a logic in the onUpdate method. If we press the escape key, we can switch from the locked to the unlocked state and vice versa. Let's see if it works. And it worked. So now we can finally turn back to the player class and we can finally move our camera inside the game world. So let's check with the is key down method the famous WASD keys. Then let's add the forward and rightward float attributes. And let's reset them each time onUpdate method is called. At this point, if we are pressing the W key, let's set the forward attribute to 1. This means the camera should move forward. If we are pressing S instead, we should set the forward attribute to -1. In this way we should move the camera backward. Let's do the same thing for the rightward attribute with the A and D keys. These are all the things we have already faced in the previous tutorials, so we can go ahead quickly. Let's see if it works. And it worked. So now we can finally start to create the 3D level. So let's go to my game class and let's start to add a floor in our game world. So in the onCreate method, let's start to load the terrain.obj file. Then let's load the floor texture. Let's also create a material specific for the floor. Let's call it floor mat. And let's use always the same myMaterial.hlsl file. In the end, let's create the entity with the mesh component in order to show the floor mesh on the screen. Let's see if it works. And it works! The camera seems to not rotate in the correct way though. Let's fix it by going to the Matrix 4x4 class and in the Set Perspective Faux LH method, let's set in the cell at the 4th row and 4th column a value of 0. Let's see if now it works. And it works without issues. Let's also remove the code that makes the house rotate. Good, the next thing to do is to fix the way in which the meshes are currently rendered. In this moment, the vertices of the meshes are inverted along the z-axis. So in the mesh C++ file we have to negate the z value of each vertex. Let's do this for the vertex, the texture coordinates and the normals. So far so good. At this point let's go to the render system C++ file and in the init rasterizer state method let's set the front counter clockwise to true. Now we can go to the graphics engine C++ file and in the update function we should set the cool mode. So let's call the setRasterizer state method and let's use the getCoolMode method of the material class. Here, though, we should improve a bit the way in which we set the cool mode. So let's go to the material header file and let's move the cool mode enumerator into the prerequisites header file. Let's make it an enum class. And now let's replace all its references in the material and other classes. What's next? Well, let's go to the render system header file and let's rename the setRasterizer state method in setCool mode. Last but not least, let's handle a further cool state, that is the non-cooled state. In the end, in the graphics engine C++ file, let's replace the setRasterizer state method in setCool mode. Let's see if it works. And it works! Perfect, let's go ahead and let's finally add the skybox. So let's load a sphere mesh. Let's load the sky texture. Let's create the sky material. And in the end, let's add a further entity and let's use now the skybox resources. Since the skybox should be really large, let's apply a scale of 1000 units along all the axes. In order to show the skybox entirely, in the player class, in particular in the onCreate method, let's set a far plane of 2000 units. Don't forget to set a front cool mode in the skybox material. In such a way we render only the internal part of the mesh and not the external one. Let's see if it works. And it works! Now we want to apply a better lighting to the various meshes. So let's add a further shader and let's call it Skybox. Let's copy and paste the same code of the My material. In My material shader, instead, let's copy and paste the old code from the directional light pixel shader file, available even in the Assets and Libs repository on GitHub. The code is practically the same, let's only fix the texture coordinate and let's add the light direction. Let's compute the world normal and let's use it in the pixel shader. Last but not least, let's comment for now the specular lighting part. In the end, let's go to the MyGame class and let's replace the MyMaterial shader of the Sky material with the Skybox shader. Let's see if it works. And it works! Now we are rendering a better lighting. The next step to do is to add the random boxes inside the scene. So let's load the box mesh. Let's create the entities as we have already done previously, with the difference that in this case we have to create multiple random entities. Let's use the rand function to compute random positions. Let's see if it works. And it works. Let's also compute random rotations. Here we go. As very last thing, let's add the famous Sponsa model. The procedure is exactly the same one used for the previous entities. The only difference is that since Sponsa is a complex mesh, it is composed also by multiple materials and textures, which should create and load a lot of resources. So as first thing, let's load the Sponsa mesh. Then let's load all the Sponsa textures that are all available in the assets and libs repository. In the end, for each texture, we have to create its specific material. Let's use the same shader, my material.hlsl, and let's set the various textures. In the end, let's only set the mesh and add all the materials. Pay attention to the order in which we add the materials. Last but not least, let's fix the setLockArea method of input system. In this case, if we don't use the floor function, a series of issues related to the mouse movements can appear. Let's see if it works. And it works. That's all for now, folks. Today we have seen how to finally create a 3D level with our new systems. The next time we will handle lights through components. I hope you enjoyed this video. See you soon. Thanks for watching.